Hello and welcome to one of two videos in a set. If you've clicked on this video, then you've chosen
Hot
in the
Hot versus Cold set.
Your view will be counted after accruing 30 seconds. If you'd like to boost
Hot
chances, feel free to leave a like, dislike, comment, or share this video. If you'd like to boost this video's other metrics, feel free to do so at your leisure. Likes and dislikes will be kept separate but counted similarly. Your vote for
Hot
has been counted. Thank you.
We'll determine what the odds are for a particular temperature in the solar system. We'll be simplifying things to three categories: empty space, the sun, and each planet's surface. First, we'll tackle empty space. For this, we'll use the cosmic microwave background temperature of 2.7 Kelvin or negative 270.45 degrees Celsius, being just 2.7 degrees warmer than absolute zero. In terms of area, we'll say it takes up any leftover space, even though realistically speaking, this may not be the truth. Next, let's target the sun. The sun's solar atmosphere consists of the photosphere, chromosphere, and corona. The sun's solar interior consists of the convective zone, radiative zone, and core. Next, we'll determine the size and temperature of each of those areas. The area for a sphere with radius r is given by the following formula: 4/3 pi r cubed. For our calculations, we'll round pi to 3.14. The radius of the sun is 695,508 kilometers. We'll ignore the sun's corona, similar to how we'll ignore each planet's atmospheric and core temperatures. The sun's corona extends millions of kilometers into space and can easily get over 1,000,000 Kelvin. For the photosphere, it has a thickness of 500 kilometers and averages 5,500 degrees Celsius. To ascertain the general area for this 5,500 degrees, we'll subtract the sun's volume from the sun plus photosphere's volume to get 3.056 times 10 to the 15th kilometers cubed. For the chromosphere, it has a thickness of 2,000 kilometers and ranges from 4,000 degrees to 20,000. So we'll say the average is around 10,000. We'll use the same process as earlier, subtracting the sun plus photosphere's volume from the sun plus photosphere plus chromosphere's volume to get 1.218 times 10 to the 16th kilometers cubed. For the interior of the sun, we'll start with the core. The core is about 20% of the radius of the sun, or about 139,102 kilometers thick and around 15 million degrees. The area is just 4/3 pi times this 139,102 cubed to get 1.1268 times 10 to the 16th kilometers cubed. The radiative zone is about 50% or 347,754 kilometers thick and ranges from 2 million to 7 million, so we'll say about 4.5 million for the overall average. The area is taken by adding the core's radius and calculating that volume and subtracting the core's volume to get 4.7187 times 10 to the 17th kilometers cubed. For the convective zone, it's about 30% of the sun's radius, or 208,652 kilometers. It starts at 2 million and decreases to 5,500 as it approaches the surface. We'll say the average is 1 million. The area is taken by a similar approach, this time subtracting the radiative zone and core volumes to get 9.2542 times 10 to the 17th kilometer cubed. Next, we can focus on the planets. We'll be ignoring their cores/interior in the final calculation. In general, surface temperatures of planets decrease with greater distance from the sun. The average surface temperatures for planets are as follows: Neptune, negative 200 degrees. Uranus, negative 195 degrees. Saturn, negative 140 degrees. Jupiter, negative 110 degrees. Mars, -65 degrees. Earth, 15 degrees. Mercury, 167 degrees. Ending with a boiling 464 degrees for Venus. For the gas giants, the average surface temperature is taken at the 1 bar pressure level in the atmosphere, equal to the sea level atmospheric pressure on Earth. The surface area for a sphere with radius r is given by the following formula, 4 pi r squared. We'll calculate both the surface area and the volume for each planet. For Mercury, with a radius of 2,440 kilometers, this results in about 74 million kilometers squared, or about 60 billion kilometers cubed. For Venus, with a radius of 6,052 kilometers, this results in a value of 460 million kilometers squared and 928 billion kilometers cubed. For Earth, with a radius of 6,378 kilometers, this results in 510 million kilometers squared and 1 trillion kilometers cubed, approximately. For Mars, with a value of 3,396 kilometers for its radius, this results in 144 million kilometers squared and about 163 billion kilometers cubed. For Jupiter, its radius is 71,492 kilometers, and its surface area is over 64 billion kilometers squared. Its volume is 1.5298 times 10 to the 15th kilometers cubed. Saturn has a radius of 60,268 kilometers. Its surface area is over 45 billion kilometers squared. Its area is given by 9.1649 times 10 to the 14th kilometers cubed. Uranus has a radius of 25,559 kilometers. Its surface area is over 8 billion. Its area is given by 6.9904 times 10 to the 13th kilometers cubed. Neptune has a similar radius of 24,764 kilometers. Its surface area is about 7.7 billion kilometers squared. Its area is given by 6.3582 times 10 to the 13th kilometers cubed. We'll also use Neptune's distance from the Sun as the radius of our solar system. For our purposes, the solar system's radius is approximately 30 astronomical units, or 2.8 billion miles, or 4.5 billion kilometers. This gives it a volume of 3.8151 times 10 to the 29th kilometers cubed. It's time to calculate the odds of temperature within this area given our limited parameters. For the sake of keeping the units all the same, I'll use each planet's volume instead, even though the temperatures we'll be using is still just an average for each planet's surface area. We'll start with our smallest areas and work our way up. Mercury takes up about 1.5942 times 10 to the negative 17th percent of the solar system. That's 0 decimal followed by 16 zeros, 159%. Mars takes up 4.2980 times 10 to the negative 17%. Venus takes up 2.4325 times 10 to the negative 16. Earth, 2.8472 times 10 to the negative 16. Neptune, 1.6666 times 10 to the negative 14. Uranus, 1.8323 times 10 to the negative 14. Saturn, 2.4023 times 10 to the negative 13. And Jupiter, 4.0096 times 10 to the negative 13. The photosphere, although larger, still only takes up about 8.0103 times 10 to the negative 13% of the solar system. The core, 2.9535 times 10 to the negative 12. The chromosphere, 3.1926 times 10 to the negative 12. The radiative zone, 1.2368 times 10 to the negative 10%. And the convective zone, 2.4257 times 10 to the negative 10%. Collectively, the area of all the planets and Sun amounts to 1.425 times 10 to the 18th kilometers cubed. Of course, this doesn't account for the area that the corona takes up or any moons or other astronomical objects. Nevertheless, we will use this value to then calculate the remaining percentage, that being given by the cosmic microwave background of negative 270.45 degrees Celsius. That leaves approximately 99.99999999626%.
Thanks again for showing your support for
Hot